In this video, we'll be looking at arithmetic series. So just a reminder, an arithmetic sequence has a common difference. So for example, this sequence, 2, 5, 8, 11, you're adding 3 each time. So this is an arithmetic sequence. And our general formula for an arithmetic sequence is an, which is the term, is equal to a1, which is the first term, so in this case 2, plus d, where d is the common difference, so in this case it is 3, and then n minus 1, where n is the position number of a term in the sequence. Now an arithmetic series is the sum of an arithmetic sequence. So for example, if you take that sequence 2, 5, 8, 11, if you write it as 2 plus 5 plus 8 plus 11, that is now an arithmetic series. And you have two potential formulas that you can use. The first one is taking a1 plus an. So that is your first term plus your last term and multiplying it by n over 2. And n over 2, n is the total number, the total numbers in the sequence, and cutting it in half. So you're pretty much pairing everything up. Okay, so for example, in this sequence, let's just say that we had these 4 terms. A1 is 2, 11 is the last term, 2 plus 11 is 13. You might also notice that the middle 2 terms, when you add them up, you also get 13. And if you check this out, we have 2 pairs of a sum of 13. And we have 4 numbers. So 4 divided by 2 is 2. So n over 2 actually represents the number of pairings you have of the same sum. And the sum is always going to be taking your outside numbers and adding them. So 2 plus 11, 5 plus 8, and so on. So that's one of your formulas. The other one comes from this. So let's just say I take this an, and instead of writing an, I write the general expression. So n times a1 plus, and now I'm just going to write a1 plus dn minus 1, and then all over 2. Well, if you notice, if you collect your like terms, you now get 2 a1s, and then the plus dn minus 1. So that's where the second formula comes from. All right, so let's take this and try some various questions out. Okay, so example 1, determine the sum of the first 12 terms in the sequence given that the first term is 6 and the 12th term is negative 16. We're given the first term, we're given the last term, so we should use that first equation. So we're finding the sum of 12 terms. N is 12 because there are 12 numbers. And you can put it all over 2 or just a 12 over 2, but 12 over 2 is 6. So you have 6 pairs. The first number is 6, and I'm going to add it to the last number, which is negative 16. So 12 over 6, 6 pairs. 6 plus negative 16 is negative 10. So each pair has a sum of negative 10 to get negative 60. So the sum of the first 12 terms is negative 60. All right, for our next example, we're determining the sum of the first 20 terms in the sequence negative 10, minus 6, minus 2, plus 2, and so on. So we're not given the last term, which you're more than welcome to solve for it. You can find a20 using the general arithmetic sequence formula, but I'm not going to bother with that, and I'm just going to use the second version of my series formula. So I know that there are 20 terms, so n is 20. I know my a1 is negative 10. My common difference, it looks like I'm adding 4 each time. And that's it. So the sum of the 20 terms is equal to n, which is 20, times double the first term, which is negative 10, plus the common difference, times 20 minus 1, all over 2. You can do this all at once in your calculator. I'm just going to simplify that big bracket, so 2 times negative 10 plus 4 times the 19, and you get 56, and this will give you 560. So the sum of the first 20 terms is 560. All right, determine the sum of this arithmetic sequence. 41 plus 34 plus 27 plus 20 all the way to negative 15. Now, in both of our series formulas, we need to know how many terms there are. And we don't know that, so we have to calculate it. But here's what we do know. We know that our first term is 41. And if I look at this sequence, it looks like I'm subtracting 7 each time. So my common difference is negative 7. And my goal here is to figure out what n is equal to. So because right now I'm just looking at the actual sequence, not this series, I'm going to use my sequence formula. And I'm going to fill in what I have. I know my final term is negative 15, so I'm going to put negative 15 in there because I want to figure out what position it's in. So figure out what n is. A1 is 41, subtract 7, and minus 1. And now let's just isolate for n. So I'm going to bring the 41 over to the other side to get negative 56. Here, if you want, you can distribute the negative 7 in, or I'm just going to divide both sides by negative 7 to get 8. And then we can bring that negative 1 over to get 9 for n. So there are 9 terms in this sequence. Now that we have n, and we have the first term and the last term, you can actually use either arithmetic series formulas. I'm going to use the first one because it's a little simpler. So I'm finding the sum of the 9 terms. A1 is 41. My last term is negative 15. And I'm going to divide that all by 2. I'm just going to do this all at once in my calculator. And I get 117. So the sum of all of these terms is 117. All right, so for the next one, we're actually going to be given the sum. So the first 20 terms in an arithmetic series have a sum of 770. So that just means S20, sum of 20, is 770. The common difference, D, is 3. What are the first 3 terms of the series? So that means I need to figure out what A1 is equal to, so that way I can come up with those first 3 terms. So here I have to use my longer equation, so n2a1 plus d, n minus 1, all over 2. So I know what the sum is. I know it's 770. I know I have 20 terms, so n equals 20. I don't know my first term, so I have to keep 2 times a1. I know the common difference, and then I can write 20 minus 1 all over 2. And now I want to clean this up. So you can do this in different ways. I'm just going to simplify this 20 over 2 to get 10. And then I'm also going to simplify 3 times 20 minus 1 to get 57. And now we can divide both sides by 10 because our goal is to isolate for A1. So 77 equals 2A1 plus 57. We can bring the 57 to the other side. So 77 minus 57 is 20. And divide both sides by 2 to get 10 for our A1. So now that we have our first term, and we know that the common difference is 3, the first term is 10, add on 3, we get 13, add on another 3, and we get 16. And these are the first 3 terms in the series. Okay, let's go to our last example where we have an application problem. So a Greek theater has 30 seats in the first row. Each row behind the first row gains 2 additional seats. If the theater has 22 rows, how many seats are there in total? So the word total should make us think of a series because we're adding up all of the seats. So our first row has 30. Then each row gains 2. So the next one has 32, then 34, and so on. So we know our A1 is 30. We know our common difference is 2. And we know that there are 22 rows, which means n is equal to 22. Now, again, if you would like, you can solve for the 22nd term and then use that first series equation, but I'm just going to use the longer version. So the sum of 22 terms is equal to n. So 22 times 2 times A1 plus the common difference times n minus 1 all over 2. And if you want, you can clean it up here. So that big bracket simplifies to 102. And this whole thing simplifies to 1,122. And because this is actually a word problem, we do need a therefore statement. Therefore, the theater has 1,122 seats. And that's it for this series. So you have two different formulas that you can work with. Sometimes you do still have to use the arithmetic sequence formula first, but that's it.